example from the University of Mumbai.
Such a sequence limit. A very typical limit for such an application. But of such a method, I called it multiplication by conjugation. I show exactly how to apply this method in my course. And here I will show you only slowly, step by step, this specific example. So, what now? I am rewriting it into our math Kiwi.
I hope you will help us with this example, Kiwi.
And what needs to be applied here is the so-called multiplication of the numerator and denominator by the conjugate for this subtraction with roots. I multiply the numerator and denominator by the same thing, so it's like multiplying by 1, but by what? By this subtraction with roots, but with a plus sign. Now look. I chose the same thing that's here in this subtraction with roots, but I changed the minus to a plus. Did I do it right, Kiwi? Yes. What will that give me? In the next step, I move it to the numerator, and you might already notice. And perhaps you will already notice that here is the formula for the difference of squares. The one for a plus b times a minus b, that it is a squared minus b squared, right? Right? So instead of this here in the numerator, I can write that it will be the first root squared minus the second root squared. Is that correct? Correct. From this formula of shortened multiplication, right? The square root squared will simply cancel out. So it will be like this. On top and minus n will cancel out. But I suggest making a small mistake. Let's say we are tired. We make such a mistake. A mistake. Let's ask Kiwi. Where is this mistake?
You'll give us a hint there, Kiwi. Where did we make a mistake?
Well, yes. Instead of that, we should move to this. So there should be a 1 in the numerator, as Kiwi rightly pointed out. Thank you. We correct it. Now it's correct. The square root of n, which I was just passively copying until now, I'll put it in the numerator. And I have this. What next, ladies and gentlemen? Now, in this slightly more difficult example, I use a method that was already in the third example from the tasks from this university in Mumbai. I factor out the highest power. I also slowly discussed this method in my course. Here it will be a slightly more difficult variant of this method because first, under this root, the highest power needs to be factored out. Look, I'll do some factoring.
Here, under this root, I extract the largest power, which is simply outside the bracket, so it will be like this.
Will Kiwi agree?
Yes, Kiwi agreed. Now, I break this down into two roots. Here, the root of the first times the root of the second.
Great. And now at the bottom in the denominator, I sort of take the square root of n out in front from this component and from this component. Right, it will be something like this. The square root of n and the square root of n on the top and bottom will cancel out, but the top won't disappear. There will just be a 1.
Well, so the bottom will of course be
the same. And here I can already write down what this is all leading to. If n approaches infinity, then 1 over n approaches 0 because it's a constant over infinity. In my course, I showed that a constant over infinity always approaches 0 because, well, this infinity, the denominator is getting bigger and bigger, so it approaches 0. So what do we have left? On top 1, at the bottom, the square root of 1 plus 0, which is the square root of 1, which is 1. 1 plus 1 is 2, so the entire result is 1/2. A slightly more difficult example, perhaps. Thanks to Kiwi for the help, by the way. I didn't show you the whole method here. I call it multiplication by conjugate from the basics, how to do it, but straight away, how to apply it in this specific example from the University of Mumbai from the year 2019. If you're curious about this method, how to apply it in other examples, I warmly invite you to my course. And that's it for now. Good luck with your study. Bye.